Hello everyone, welcome to my channel. I am still busy with integration, and in this video I have one integral that I would like us to look at, and it's the integral of x cubed plus 1 all over x cubed minus x dx. The approach is as follows. So we have the integral of x cubed plus 1 all over x cubed minus x dx. Let's call this page 1. Now, looking at the numerator there and the denominator, I think it's better for us to factorize both the numerator and the denominator. In the numerator, if you agree with me, we have the sum of two cubes. Factorization is as follows. We take cube root of x cubed, the answer is x. Cube root of 1, the answer is 1. We respect that sign in between there. The next expression is going to be the square of x is x squared. X times 1 is x. We change the sign here, it's plus, and we have to have a minus there, and then 1 times itself, the answer is 1. We're dividing this by, in the denominator, we have the common factor of x, and we have x squared minus 1, if you see what I mean there, dx. Difference of two squares here, we have to factorize this part, is this part here, as follows. We have x plus 1 in the numerator, and then x squared minus x plus 1 all over x, difference of two squares, like I said, x plus 1, x minus 1 dx. Next, this cancels that, as you can see. So what do we have in the numerator? We have the integral of x squared minus x plus 1 all over. In the denominator, we have x times x minus 1 and then dx. Now, looking at x squared minus x and then x times x minus 1, I think it would be wiser to distribute this x in the denominator and see what we get after that. So this will be the integral of x squared minus x plus 1. We're dividing this by the integral of x squared minus x dx. Now you can see that now it is wiser to use term-wise division. Divide this expression here into that and that separately. Of course, there's a plus sign in between there. Taking us to page 2, we proceed as follows. So we have that integral changes to, I said, the integral of x squared minus x. We're dividing that by x squared minus x, and then we have to say plus, that plus sign there, 1 all over x squared minus x, and then we have to say dx. Now this is page 2. Now you can see that that's just 1. So we're saying now the integral of 1 plus, and let me factorize this to 1 over x minus 1, and then we have dx. Distribute the integral and dx. You're going to get the integral of 1 dx, and then plus the integral of 1 over x minus 1 dx. Integrating x with 1 with respect to x, the answer is x plus, let me say I here because I want to evaluate that separately. Now, what is our I? Well, our I is the integral of 1 all over x minus 1 dx. Now I have to evaluate this by using partial fractions. So what I'm saying now is the following, basically 1 all over x minus 1. We have two linear terms in the denominator multiplying, so we can rewrite this as a over x, and then we're going to say plus b all over x minus 1. So we simplify the right hand side, taking us to page 3. Simplifying the right hand side, what do we get? We get the following. On the left, we still have 1 over x minus 1. On the right, we have the common denominator is going to be the product x minus 1. we take this into the denominator, the answer is x minus 1 times a. So what we have is a times x minus 1. And then there's a plus sign there. That one we respect it. X minus 1 into that, the answer is x times b in the numerator, where bx. Right, now two fractions are such that the denominators are the same. Therefore, if the two fractions are the same, numerators must be the same as well. So this implies 1 is actually equal to, let me expand that. Maybe let me keep it like that for now, like this, plus bx. Let me rewrite the left-hand side to 0x plus 1. You'll understand shortly why. Let's expand this. So it's ax minus a plus bx. I'm going to collect like terms together on the right-hand side. I have ax plus bx minus a, bx minus a equals 0x plus 1. Now factorizing here, the common factor is x. I'm going to have a plus b times x minus a is equal to 0x plus 1. Coefficients must be equated, that equated to that, and of course the constant term equated to the constant term. So basically we're saying a plus b is equal to 0, a plus b equals 0, and then on the right hand side, if we continue, maybe we have minus a equals 1, minus a equals 1. So solving for a here, a equals minus 1, and bringing this one to the other side, we have minus 1 plus b equals 0. Solving for b, you'll agree with me that b equals positive 1. So now we have the two values of constants a and b. It means that we can rewrite integral I. This is page 3, taking us to page 4. Remember, a is minus 1 and b is 1. So we're coming back here and we're saying this integral then, and this is now page 4. We're saying this integral then, this integral there. Let me move this one down. Okay. So we're saying that this integral here, I is equal to the integral. Instead of this expression here, I'm going to have to replace it by that. So it's going to be the same as a is minus 1, remember, all over x, plus b is 1, all over x minus 1. And then we are saying dx here. Now distribute integral and dx. You're going to get the following. The integral of minus 1 over x dx plus the integral of 1 over x minus 1 dx. Now, this here, take minus 1 or minus out, minus 1 obviously, 1 over x dx, and here we have just have 1 over x minus 1 dx. The integral of 1 over x is natural log of x. The integral of 1 over x minus 1 is natural log of x minus 1. Let me write the positive term first. This is natural log of x minus 1 minus natural log of x. Using this law of logs, basically saying the natural log of m over n equals natural log of m minus natural log of n. This form here is this form that you see here. So I can divide now to get this part here. So this is the same as natural log of, watch this, x minus 1 all over x, which simplifies to natural log of x over x minus 1 over x. And it gives us the final step in this one of natural log of 1 minus 1 over x. I'm going to leave it in this form. Right, so that's our I. But remember where we're coming from? We're coming from x plus I. So basically we can now conclude and say, taking us to page 5, just to finish this off. Page 5, we're going to say, therefore, the integral of x cubed plus 1 all over x cubed minus x dx. Remember, this is where we're coming from. Over here, that's the integral there. must simplify to x plus I. And what is our I? Here is our I. So we're going to say this is equal to x plus natural log of 1 minus 1 over x. But don't forget to say plus c, because we're dealing with an indefinite integral here. That's our final solution. Right, like I said, I had only one integral in this one. Your feedback remains very, very critical for us, because it helps us to plan on how we are supposed to present information on this channel. All right, I'll see you in the next one.